the more I learn. The more I learn, the more I realizes, the less I know. With this beautiful quote of Michael Legrand, I, Tanu Dua, welcome you all on behalf of Satyug Darshan Institute of Engineering and Technology to the second day of International Symposium on Data Science. I hope you are all safe and rested for the day and ready to rejuvenate yourself from today's session. Let me introduce the resource person for the day, Mr. Lalit Saraswat. Sir has done BTech from YMCA and MS in Management Information System from University of Arizona. Lalit Saraswat sir has a decade of extensive experience in IT industry. Presently, he is working as a full stack software engineer at Solera Health USA. Previously headed as a lead software engineer at Appflow Solutions, he has also worked with L&T Infotech as software engineer. He is well versed in Microsoft Azure Cloud, MongoDB, and has a vast knowledge with hands-on experience on different frameworks like Express, Spring. We are honored by your presence, sir. Let us all welcome Mr. Lalit Saraswat, sir, for today's session. Over to you, sir.
Thank you, Tanu, for such a generous introduction. I feel privileged to be part of this symposium. Uh, I know these are challenging times, and all of us are being stationed at our work desk in our homes. So, not the best of times uh, to have such a discussion in a personal space. But I believe that we are all following social distancing norms, and we are all uh, staying healthy and staying good. Uh, Even though it's evening in Faridabad in India, it's pretty early morning here, so I might fumble a little. I just woke up, uh, so do take that in mind. And I'll start sharing my screen, and let's go ahead with the presentation for today. So yeah, the agenda for today is that I'm going to introduce like my perspective on how the software development is changing in these times. Like I've been in this industry for almost a decade. Uh, I started my career in early 2010, and then I worked in a couple of companies in India. Uh, then I thought that my career was approaching a plateau, so I thought to expand my knowledge, and hence I came to US and enrolled in this master's program. So post that, I'm working in Solera Health Incorporation. It's a healthcare startup here in Phoenix, Arizona. And as Tanu mentioned, that I am a full stack software engineer over here. As part of this presentation, we will uh, discuss these software developments which have been happening uh, like over the decade, like how these things are evolving. And towards the end of presentation, we'll also touch a little bit about uh, case study which I did last year, and which will throw some light on how data management and analysis is done uh, in a new perspective, having a different problem statement which many of us are not aware of. I was fortunate enough that while I was working in that department while doing my masters, this project came across, and I got to make a team with a few PhD candidates, and it was a very fruitful team, and I learned a lot. And so it's my honor to take you guys through that presentation which I have. So let's take this thing forward. So just like I said, this is my introduction. Uh, I have almost 8+ years of experience. I graduated from LR College of Management last year, and before that, I worked into different companies in India. And before that, I graduated from the YMCA Institute of Engineering, so which is now obviously YMCA University. So those were the days like it was being changed from a autonomous institute to a university. So long time. So I understand that the audience of this symposium is from different backgrounds. There are people who are students, obviously. There are people who are teachers. There are research fellows. There could be some people who won't have much of experience in computer science, and many other things won't make a lot of sense to them, or those who are early in their graduation, a lot of things won't make sense to them. So I make a conscious decision to make sense to everyone by uh, not having an exhaustive discussion, and we'll stay away from some of the buzzwords. Of course, I can't avoid all of them, uh, but if you have any questions, feel free to interrupt me, and we'll also have a Q&A session towards the end of this discussion. Uh, and Through this journey, I'll try not to get too much technical because I understand like this is a less than an hour of discussion, and we can't go into too much depth. So agenda for today. So like I mentioned in the introduction, uh, we'll understand this software development, how it used to be when I started my career, and how I've seen few emerging trends, and like all the things which you will see in this presentation, these are like the things which just came off my head. So I did not uh, think too much. Like these are the things which you would hear from any experienced person, like having a discussion, like your elder brother or those kinds of people, like who are versed into technology, and they will give you some non-bookish knowledge. So that kind of stuff I have tried to come up with. Uh, I hope that this will suit everyone, and I mean, the knowledge, of course, the trends we will be seeing in technology, they probably won't suit every problem. Uh, in the middle of discussion, we'll also touch few basics of cloud. So, uh, like currently, I'm working with Azure, so I thought that maybe Azure is a very good platform, which is a whole composite thing uh, with regard to software development and and data management and even data analysis. Uh, a couple of days ago, they also came up with an API which any subscriber can use to do some text analytics. So we are discussing this journey of software development over past few years, and we'll be taking on like we'll be starting in reverse, like what is the modern development as of now. So in order to understand that thing, we have to first uh, understand what is not modern any longer. Like when I started my career, there used to be different things which I don't see they exist anymore. So so most of you like who are probably in their first year or second years, you might be reading about software development life cycles and waterfall model. So humbly I say it does not exist anymore in the development world. There are new technology, new techniques of development, new project management things which have overtaken this thing. So SDLC is out as far as the waterfall model is concerned. Agile is in. Uh, Also, there used to be a monolithic architecture of different application development, like when things people used to devise their things and like work on the architecture of applications. So like if you are developing some application in Java world, you develop some WAR file and you deploy that on a server, like as far as academic projects are concerned. So that could be an example of a monolithic thing, like all the things which you require as part of development all are contained within a single unit. Okay, so yeah, these are the problems which we have generally in a long distance communication over Zoom. So bear with me, and as we go through this, I hope things will streamline. Uh, so yeah, we're talking about the things which are not any longer modern. So we said that the waterfall model it has ceased to exist in most of the applications which are people are incepting right now. Monolithic architecture is gone, where things used to be in a self-contained world, like for example, you are deploying a WAR file on a server, so everything is contained in that WAR file. So that's currently out of picture. Uh, Next is after this monolithic architecture, there was something which came up, which was called a service-oriented architecture or SOA, where this application used to have different modules, and those modules used to talk to each other through some protocols, and even with some other applications running on some other servers, there used to be a communication using web services. So uh, right now, even that part is no longer used in and in industry, like as far as I know, rather than few legacy applications which might be having it. Modern applications, they try to avoid this kind of architecture. They are more inclined towards other things, which we will see in next slide. Uh, Also, having applications on personal servers, it's unless it's a very sensitive domain like banking, I don't believe that there are applications which people prefer to be going on their own servers, which they are hosting on their own premises. So that's also out of picture now. Uh, and the last thing is complex integration. So with these advancing times, integration of different applications, it has improved a lot. And once we are done with initial configurations, things become pretty easy. And we'll see going forward, like how cloud is helping us achieve all these things. And of course, the complex integration involves the patch management, which suppose there is some change request to some code base. So how you are going to do that? That involves a lot of complexity. Like you have to stop the application, you have to request a downtime. So your application also goes through a few phases. Like if you're into that downtime, it's off, right? Nobody can access it, and you have to be very sure that whatever patch you're applying, it goes through. And if you're saying that you're taking 30 minutes for that thing, it should not. Otherwise, users of that application, they will be like they won't get any response if they try to hit that application. So that's one thing. And of course the downtime. So what is happening currently is that we are experiencing a paradigm shift in this software technology, uh, uh, like different domains. Like as far as the architecture is concerned, so earlier, like I said, there used to be monolithic, then service-oriented architecture. Now what we are currently seeing is called as a microservices architecture. So microservices are basically like a big application decomposed into say, several small application, and these small applications, they communicate with each other through REST APIs. And uh, client facing side also has a service which, let's say, there's an application which has a web user interface. So I, as a client, I'm only interacting with the web UI or a mobile interface. But on the back end, that UI has a lot of connection to other web services. It might be connecting to some service which is, let's say, responsible for authentication of different users, or giving them different authorization to access few pages. They should or they should not. There could be service for enabling service bus connections like the message queues and message brokers. So we try to come up with as many services as we want and which suit our need. So they could be based on business classification or technical classification, but overall, on a high level, their communication is mostly on through REST APIs, and there's an API gateway. When we see Azure, we'll again bring up this point, how things are configured, and how this has made life of a developer pretty easy nowadays. So once again, we'll iterate. It's a distributed architecture. It comes with different benefits, like you have separation of concerns. Like if you remember, like few minutes ago, I said that either our application is on or off. So when your application is distributed, it can be in both states. So let's say in this example, if user service, some developer is working on that, he's pushing some code. So he can push down that service, and in concurrence, other services will always be on. So if other developers are working on other things, so their work won't get affected. Or if other customers are using those things, their work will not get affected. So this distributed architecture, it enables such separation of concerns, and the developers responsible for them, they don't have to worry about the other things. So when they're in development phase, they just have to see that their code goes through, and it automatically integrates later. So so like I said before, if we can have different kind of services, like for authorization, authentication, or if we have some mail service enabled. Like a few days ago, I integrated a SendGrid mail service into our application. So even when the SendGrid is down, or our messages are in the message broker, so it does not affect the other part of application. So that's the benefit of having a distributed architecture. So let's take our discussion forward, and let's see what are the other changes with this paradigm shift. So Other thing which I want to touch upon is software development, like how it used to be when I started my career, or uh, how it is taught in colleges, even to this day, because things are changing at such a pace that you cannot counterbalance it with uh, change in curriculum every now and then. You have to be good at basics. So once you're done with basics, you have to be updated with all the practices which are going on in the industry, and uh, uh, like the things which are coming up. For example, like uh, as far as programming language is concerned, so earlier there used to be different designated teams for handling an application, for developing it, for managing it, and like a designated person will look towards the UI part, someone will look towards the back end, some different person will take care of all the middleware. So that thing is slowly going out of picture. So we now have resources who are trained, or who have knowledge of different things, and the thing which binds them together is most likely, in most of the cases, it's a single language. So as far as our application development is concerned, and this title of full stack engineer is concerned, the idea behind is that he should be capable of handling uh, every part of that application. So whether it be front end, whether it be back end, or middleware, or mail service, or anything, so he should be adept to take care of any part when required. And language as a barrier should not exist. So someone who is well versed in Java there should not be a situation that if he's given a let's say assignment in some other programming language, or if he's given some front end work, so he should not move away from it. It used to happen. I've seen it happening, but nowadays even as far as the development is concerned, so let's say for my project, we have on a high level we have JavaScript, and we use various versions of JavaScript for handling different parts, like TypeScript for the backend part, which mostly resembles other programming languages also. So there's obviously a little hurdle when you jump from one language to other language, but once when you do, you gain that ability to be able to program into any language, and that's what this full stack engineering is all about. Uh, and other things which have evolved in this programming, like how developers they program, are uh, like even though oops we all study oops in engineering, and oops has been like the bedrock of every software development uh, uh, ever initiated. But there have been some limitations with oops as well. uh, I'm not a computer science graduate, but I do understand there are computational mathematics involved, which led to the design of these languages. So that's how OOPS came up. And now there is a different paradigm developing, which is called as a functional programming. So it's based on some mathematical functions that you give a definite input and you get a definite output. So your code, it's not a series of statements. It's a single self-contained block which takes a specific input and gives you an output. So you're not uh, too much concerned about how it processes it. In other words, it could be, I mean, some of you could refer to that as abstraction, but functional programming is uh, it's like a mathematical function to imagine it. Uh, you have all the chunk of code in a block. There are no sequence or lines of codes like there used to be before that. Another programming style is test-driven development, TDD. So it comprises of very short development cycles. So let's say you have been given a scenario and you have to develop a solution for it, and you take some time, and then you come up with a solution. But you know that this part has not been tested, and there could be some changes coming to it from customer, or from your manager, or from some uh, program manager involved in your development process. So if you get again new development requirements, you'll have to code again. So what we do is once an initial draft of let's say a code base is done, we devise some test cases around it, and we try to keep our interfaces always consistent. And whenever we do iterations of coding or improvement over that piece of code, we run it through the same or improved test cases. So it makes sure that our code is pretty robust, and that we are not missing anything, and that several test cases, which are general unit test cases, they take care of all the boundary constraints, all the conditions involved. So that's a new thing which has gained a lot of mileage in recent years. Another thing is that like many of you might be familiar with the programming styles and how we used to have uh, let's say for example in Java world, you when you build a project, you have to import a lot of jar files, and uh, so you have to keep track of all those jar files which does what, and you have to be very careful about their versions and all. So slowly that part has been taken care of by designated package managers. Like if we talk about Java itself, there used to be Gradle and then Maven. And when I moved to this JavaScript thing, there are package managers through which take care of all the like the requirements which we have. So we don't need to manually go there and put some jar or some package which we need as part of development. So we have a configuration file, we make some changes, and then it automatically imports that specific file and that specific version number. And that package does not necessarily come from a public repository. We could also have a local repository, artifact, which we can always import and keep track of. Another thing apart from package manager is package scanner. So this thing has also gained currency in recent times. Like whenever you are importing some packages from some repository, so there is always a chance of importing some malware or some software which you need not have as part of, or which could pose some problems to your application in future. Like so package scanners, they are the hosted services which run your package through some designated tests, and you get to know that which packages are valid and which do not have any malware. So that's another programming thing which is very much in vogue these days. So we should be aware. Another thing as we go forward in paradigm shift is integration and deployment. So it used to be a pain in neck a few years ago when people have to, if you are aware, like of version control systems, there used to be subversion or SVN. So there used to be a common trunk where everyone would come and merge their code, and there used to be so many conflict issues, and then someone will check out the code from it, and then it will go to server. So it all used to be a very manual process. With times, that process is a lot of that part is automated. Uh, what we call it these days is CI/CD pipeline. Uh, so it takes care of all the deployment thing. So whenever you push code, I'm taking example of a version control like Git or Bitbucket. So when you push code and then it gets merged without any conflicts, and your branch gets let's say pulled into the master branch, and then code is checked out, and then it's pushed into production. So that journey, it has to take that journey through uh, uh, philosophical thing like a pipeline. So that when that code passes through that pipeline, there are a series of tasks which get executed on that code, uh, which again, like I said, there could be package scanners. So just an example I've kept there, it's the scanner which I'm currently using, it's Snake. Uh, they could be like the test cases which we had, we can automate all of them. Once code is passing through, we can again double check, like code should pass all of them. And also, like, there's a concept of code coverage. Like let's say you have 100 lines of code in some module, and you have a unit test which covers only 10 lines of that code. So your code coverage is essentially 10%, and it's a very bad practice to have that less coverage. So ideally, like, it should be 60, 70 minimum. You could keep a check for code coverage within that pipeline, and if you're not reaching that coverage, then your build should fail. And another part of this CI/CD pipeline is containerization. Like, you might have heard these words called Docker and Kubernetes. So these are like basically configuration files which bundle your application with all the requirements, and then it gets pushed to any virtual environment where it can get deployed. So different applications which are containerized can get hosted on a single virtual machine also. So these are all part of CI/CD pipeline, and it's again, like I said, it's how things are changing. It's a lot of automated process. So having said this, post paradigm shift, like we come to a question like what had been going, like was it all very bad, or does it not suit anyone anymore? So that's not the case. Old solutions, they are still very much in practice. Like I said initially, there are legacy applications working in banking domain, healthcare domain. uh, I went to a company like last year, and they had their mainframes and their code running in languages which I had not even heard of. 35 years old code running on some monitors, and even their monitors had turned cathode ray tube monitors, and they had turned black on some parts. So you can't change those things, and they are very reliable, pretty solid things. So we have to have them running, and if anything comes for a change in there, then we'll have to follow the same practice. So it does not suit everyone. Like we say that no one size fits all. Uh, Another thing I kept is suitable deflection. So like it's a all of you can recall physics experiment, like we used to pass a ray of light through a prism and it gets diffracted in different wavelengths with your violet, indigo, blue. So like depending on your need, you can pick your diffraction level. So if let's say for a microservices architecture, so I want 10 different microservices working in different environments, and I want their communication to be very well versed using REST API. So I can opt for that. If I don't want that many microservices, I can obviously have few microservices or have a standalone application and opt for uh, let's say web services approach to interact with other applications. So more granularity we achieve, more complex things get, but we don't have choice. Once this configuration part is done, then things get easier, and there is a reason why these things are developing this way. So it's a tough choice for especially the business applications which have been going for years. And I'll end this section by saying that if it suits your need, and if you're developing an application which you want to last long, and you want it to, you see that it's going to scale. For example, like how this microservices word got currency. So there's a very important part played by Netflix in that. So you all know that it's a platform for video streaming, and millions of people use it concurrently. So they came up with a lot of architecture inventions in this field, and that's how they built this robust application which uh, people use. So did someone raise hand? Uh, Not too sure, like where I can get the chat window over here. Okay, let's go ahead for time being. Uh, so in this picture, like how does cloud computing helps? So in order to understand that, first, like we all are, we have been through this phase, like we are students, and these buzzwords, they don't make much of a sense. So all of you might be wondering what cloud means, or you might have some idea. So cloud is basically a concept where you share your resources with all the all the people who are interested. So these resources could be infrastructure, like you're offering processing power, computing power. This could be platforms. So if you're deploying an application, that application has certain needs. So those needs are called platform, like you are using a message broker service or such things. So that comes composite thing as a platform as a service. And there could be software as a service when you are exposing your application to different tenants. Tenants are like different companies who are using your software. Then it takes a picture of a shared commodity, right, with all the different tenants. So that's software as a service. And then there's a concept of function as a service, where you are actually exposing functionalities to be used by anyone who is interested. So so there's another word called document development as a service. So we are going to see that part, like how does cloud enables this development part? Uh, so we are going to take a look at different things which Microsoft Azure uh, promises, like it has a DevOps environment called, which we also call it as VSTS, Visual Studio Team Services. We have a resource management portal where we can request all the different types of resources which we need. Once you see a screenshot in coming slides, it will be very clear like how we use these things. And there's also a cloud-based software, cloud-based data solution called as MongoDB, uh, which since it's cloud-based, so you don't need to have any local deployment of that, and you can always make connections and request whatever you're storing in the database. And these companies, they have their servers located in every part of the world. So let's say if there are some users in India who are trying to access some information, so they did not access that information through some servers in US. So there could be servers in Europe, or let's say Singapore or India itself, which can process that request, and in that manner that latency time gets minimized. So that's helpful and an advantage of using a cloud data store. So we'll take a look at these in coming slides. So first, Azure DevOps. So Azure DevOps is it's a, remember like explained to you how development is done in cloud environment and how CI/CD pipelines they go through. So like if you see in the left-hand side column of this image, like these are the different things which Azure DevOps offer. Like you have a board which helps you to manage your project, and this board is derived from a Japanese methodology called Kanban, where uh, your as and when new requirements come, we on a high level we classify them as epics, and then we classify them as features, and then we segregate them as user stories, which any developer can pick up and then work on them. So this, the picture that you see, this is the board which I'm talking about. It's a Kanban board. Right now in the picture, like there are only 4 uh, columns, but we can have 6 as a user story moves from left to right, it gets completed. So we can have these boards. We can have different repositories over here. We have pipelines like the CI/CD pipeline, which I was talking about. We can have different test plans and artifacts like the packages which company has built. So it's a best practice to not directly use some package from any public repository. So because that package can undergo changes. So what we do is we take that package and we develop a wrapper around it. That wrapper exposes the functions which only we need. So it's a design pattern to how you use that artifact itself. So those artifacts you can have in the repository, and that you can always browse through DevOps if you are trying to connect to some uh, let's say some application through some artifact. So that's how the DevOps portal looks like, and the main menu items. Uh, uh, Apart from this development work, it's used for collaboration. Like you can see different repos, you can see different branches, you can see different artifacts, wiki pages. So when your code is moving through, let's say you checked out a branch and then you made some changes and then you pushed it in, and then let's say it gets merged to an initial branch. So that's called a pull request. And in development world, when you do some changes, that change has to be approved by senior engineers in your team. So it goes out, and then people make comments, and then like they can raise objections or they can approve your code changes. So that helps in collaboration, and that's how your code progresses from your local branch to a remote branch, and from remote branch to a QA branch, from QA branch to a branch which is going to lead that into production servers, passing through different environments, of course. So that's the collaboration part from DevOps, which is pretty useful. Uh, Another thing is like having talked about DevOps, another thing is resource management portal. So if you remember, like I initially touched a little about IaaS, which is infrastructure as a service. So if you are using some cloud-based solution, so So there has to be a interface to make request for it, to set your configurations which you want. So management portal does that part for you. So you can provision or deprovision different resources. You can monitor the health of resources which you have provisioned. You can always go and view their log traces, uh, which can help you out in case there is some problem or in case there is some issue happening. And of course, there is an API management thing when we talk of microservices. So how do those microservices, they interact with each other? They need to expose some endpoint. So that endpoint, a part of it can be within Azure, and a part of it can be accessed by outside applications. So you need an API management gateway for that part. So this is how the Azure Resource Management Portal looks like. So on left-hand side, you have different menu items uh, from which you can pick one and then provision and obviously configure that as per your use. So like in general, if you're conversed with the server client architecture or a basic web application, so that's called an app service in Azure domain. So you can request an app service and then configure it as per your needs. There are some applications which you do not need to have them running at all times. Uh, sorry. So they are like timer triggered applications. So or they could be HTTP triggered applications. So they are function apps. Then you can request a load balancer if you are distributing your application. Uh, there's a specific application called App Insights or Application Insights, which does all the logging part. It has a very inquisitive logging query feature also, so you can actually drill down to exact point where problem happened using Application Insights. Um, and then there are more resources like different databases, Azure Cosmos, or different storage accounts. So generally in an application, all the static parts which we have, like if you're accessing a website, there is obviously some image coming or some, let's say, header, footer uh, images. So we don't keep them in application any longer. Like the code part, we keep that in storage account or the content delivery networks. So every item in there has a URL through which it gets accessed. Um, and obviously you can request virtual machines and have them configured over here. So that's about the Azure Management Portal. Another thing which I talked initially was MongoDB. So MongoDB is a cloud data store, like I touched before. So it has several advantages. Like I gave that example of having databases, servers in different countries, and then that latency gets reduced. So basically, it's a NoSQL database. It's like we are used to seeing database as a row column thing and tables. So in MongoDB that does not and that's not the case. So we instead of tables we have collections, and instead of that data structure we have a JSON document. So just to give you an example, this is how the JSON document looks, and that's exactly how it's stored in the database. So we have key value pairs, and these are separated, comma separated values. And the advantage of having such a database is that you can always add uh, any key or any value whenever you need. So if as contrast to a relational database where adding a column in a table is a really painful thing. So that's the advantage of having a Mongo database, which personally I feel is the biggest thing for me, that it's pretty flexible to work with. And whenever you're like you expect that, let's say you have an application which has a high load on, let's say, weekends, so you can configure it to have scale up or automatic scale up scale down feature. So whenever there is load increasing, your database instances, they multiply or they add on, so that they can address all the requests simultaneously. And again, the high availability part, which I talked before. And yeah, this is a professional application. You get a very decent support and management from the company. So that's about the Mongo database. uh, so having talked about this application, and like you have a front end and a back end, and you are ingesting some data and it gets stored in a database, and you are processing it and you are monitoring it. But what does data do, or how do you leverage it rather than just supporting the application? So in order to understand this, I picked this example uh, from this NoSQL, and then uh, when you have to prepare reports or uh, analyze that data, it's not very helpful to analyze the NoSQL database because it's a document thing, and you need a software, a specific software which picks data from NoSQL and then does some operations over it and then moves it to a SQL data store. So in Azure environment, there's a specific service called Databricks, which is a hosted ETL service. ETL stands for extract, transform, and load. So it takes data and then runs some transformations, which you can design, like what do you want two different key value pair to combine and then end up into a single column. So you can always do those things, simple transformation example. And like it's not something which is running concurrently, like every time something is changing in your collection and you want it to get reflected into the database SQL data store. So you can schedule your jobs. So let's say you schedule your jobs to run every hour, so whenever it keeps a track of how many records are changing, and then it runs that job, and then that part of data gets migrated to the SQL database. So SQL data is pretty helpful. All the reporting softwares, they have pretty decent connectors to connect with SQL databases, and you can play around with them. So reporting is pretty successful with SQL data. And like once you do reports, how are these reports going to like bring value to the management? So they can obviously analyze different key performance indicators, see which resources are more accessed by customers, and things like this, which help management take better decision. So that's a benefit of data. Like the question which I put, what about the data? How you can use it? So also like you can derive how the marketing team of a company can derive how their pages are getting accessed by different customers. So let's say they roll out some campaign and it's getting exposed at some definite page. So, but I, as a business person, does not know how many times that page is getting accessed. So, what we developers do it, we append some tags to the URL, and whenever that URL gets accessed, so there is a process which runs, and then we track that number, like how many times this URL has been accessed. So that helps management takes decision on how successful that particular campaign was, uh, as far as like taking further decisions. Was it successful? Was it not successful? Or if there is some email campaign going out, you can always have some tracking parameters with that as well. So when these parameters they land into SQL, you can create reports and they help management take decisions. So this was a small like a pictorial representation, uh, how a Databricks takes a data from one end and then transforms it to a SQL database. So going forward, like this was the first part of my presentation. Like I wanted to give an overview of how uh, cloud is being helpful in development, and how this paradigm is changing from monolithic to service-oriented architecture and then to microservices. So going forward, like I last year I worked on a data analysis application. So my department, when I was doing masters, so there's a definite department called CMI, Center for Management of Information, and they have a pretty interesting project going on. So what they do is they've combined behavioral science with technology. So and it's a very obvious thought when you are developing some system, you cannot have it separated from arts or from social sciences. So uh, like why I brought this forward is pretty inquisitive. Like when you're talking to someone, you observe their verbal uh, utterances, how they're talking, and you observe their body language, like use of hands, or how often they are repeating words, how often they are blinking. So these make part of uh, set of observations which can tell a lot about a person's personality, or taking a step forward, like there's an application to this kind of observation of behavior and then transforming that technically into some data which possesses some meaning. So there's a subject, like a definite subject, if you want to go ahead and research, called as deception detection. So whenever someone is deceiving you or someone is cheating you, at least as far as a personal conversation is concerned, you always get a hint of it, or most of the times you do. And that was the basis of this project which was going on. And one of our professors, who is pretty well known, he created a machine, the kind of machine which you see on your picture. So it was installed at different border locations where people who are coming from across the border, they used to go, and they had a automated interview with this machine. And then what this machine will do is it would record all of their utterances, and how they are speaking. It will observe. There are different cameras installed. What is their body language? And it also had thermal scanners, like whenever someone is lying, there is a definite body response, like body temperature increases, or their eye retina, they undergo changes, like so those kinds of things happen, and it's a definite science. So we try to observe those things and create a solution out of it. So it's an ongoing project, and I picked up this project where we had to analyze real time, in real time, or near real time. Like whenever someone is saying something, we capture that sound or that voice and then perform analysis on that part. So this kind of relates to your data analysis module as well. So what I just explained, it's a rephrasing that part, that we are detecting a deception and how intentful that person is when he's trying to deceiving you through mechanized thing. So that robot is going to observe you. So I'm calling it a kiosk, but it's essentially a robot. It's going to analyze your verbal and non-verbal behavior in real time. And like I said, its application has been installed at different immigration checks on U.S. southern border, mostly with Mexico. Uh, when government changes, these things get pushed behind, or if there are some people who want to support these things, then they support. And then college, like my professor, he was telling me these things, like a particular party was not in favor of his project, and then a different party was. So things like this also play their part. Uh, and this application obviously uh, can be used in crime investigation, like when people are interrogating a suspect. So what kind of behavior does he showcases? So are you able to take cues from that behavior? Are you able to analyze that behavior and to some degree come to a conclusion that he is truthful or is he lying? So that was a big picture, but my part was pretty much limited. So my objective was to build this real-time analysis system. So I worked with two other PhD guys, and we tried coming up with this system. And as part of like coming slides, I'll try to explain what we did, what challenges we faced, and how successful was the solution which we prepared. And another thing is that like when we are doing masters, we have different courses, different credits. So you don't have like all of your time to devote to one particular project. So there are always limitations in as far as you can go. So in order to understand this part, like how you are analyzing a spoken thing, so you need different components which need to work together. You need to have an input device with a built-in or an external iPhone, like microphone, your laptop microphone, or you're having a headphone around your head. Or once it picks a signal, it's a transducer. It picks a signal and it converts that to an electrical signal, which again you should have a software running on your machine which should be able to read that input. And then uh, once that input is read, there should be a transcription of that input. Like if I'm reading a sentence to build a real-time linguistic system, so as I'm reading it, that software should be able to transcribe that part into a written text. And once that text is written, uh, there should be some algorithms, something running over it, which will help us get those cues. So so my part was to integrate all these things and then come up with a dashboard which will have those cues in place, like what actually are you getting from these things. So very high level system design. We're getting a speech signal captured by a microphone, and then there is some real time processing platform. It interacts with different APIs, speech recognition, and then something you see in a middle box, it's called Splice API. So it was a native solution from my department where uh, as and when it reads a text, it runs different algorithms and then comes up with 60 plus different parameters, like how that text performs on those parameters, what is the value which you get. Uh, and also since we are recording this input, so as a future thing, when we are talking, so sometimes our pitch goes up, sometimes our pitch goes down, sometimes we are hesitating. So that's also a feature that can be exploited for deceptive analysis. So that was a future part, but we did not implement that thing. uh, Conversation transcript features, once your transcription is done, it's stored at some place, and then uh, along with all the numerical values which we get from Splice API, we depict them on an interface with in a readable format. So that was the system design, and then the challenges were like choice of hardware which you are using, like how's the mic quality, how's the audio you are getting, and speech to text is a pretty expensive process. So when we are trying to make this real time, so there was already something which uh, was existing in the department which was not real time. It was not even near real time. It was a batch processing. So they used to have terabytes of spoken data, and then they used to run batch jobs over them, and that's how they used to come up with analysis. So it's a pretty expensive task. Uh, uh, Accuracy is not promising, uh, and when it's a, let's say when one person is speaking, then you can get a pretty good transcription. But let's say in a group, when 4 or 5 different people are talking, how can you differentiate in what they are talking? So that's called speaker diarization. And obviously you have to integrate these different components and come up with a solution in real time. So these are the challenges which we were facing. And then, like I said, Splice APIs, they used to spell out 60 plus different parameters on that particular input audio signal. So as far as deception is concerned, we have to pick like maximum 4 or 5 of them, and then like come up with a solution that, yeah, these parameters, they justify our aim of catching that deception. So high goals for one particular semester, like building a real-time system. So we still took to it, and we did our initial research, like how we could come up with the difficult part of converting work to the servers hosted at this particular company's location, and there it gets converted to a transcription, and then you get it back. So there are obviously different price tier. We for this part, this proof of concept, we used the free tier, and it had some limitations. You cannot process for more than 60 minutes a month. So why I highlighted this part is like these are the challenges which you face when you when you try to think of an out of the box solution, and you should always be prepared, and you should not like feel down or feel overwhelmed by these things. If not the perfect solution, you will at least reach somewhere, and that's what is important, that you're making some progress. Uh, Apart from these two, there was another thing called IBM Watson, which was already in use in our department, but it did not suit our requirement because it's not real time. It does not do synchronous transcription. It always like does batch processing, so it was not suiting our requirement. And once we did this experiment, uh, we came up with the different accuracy levels. So with Microsoft APIs, we had a very good accuracy. So let's say what you see in the metrics, like the top line original. So if you spoke that sentence into the mic at that point of time, the original transcript which used to come up on our console was like this. There was only one mistake which the system did. Instead of imperfect, it read or it heard imperfect. So accuracy was pretty high, more than 90% accuracy. And like you can reduce word error rate was also pretty less. Uh, uh, so we compared this with other things which are going across in different other universities, and we saw that there was a 5% error rate someone observed, and our error rate was somewhat comparable to that. And uh, it's not that we just spoke once and then we checked that transcription. We did it multiple times, and that's how we came at that number. So with Microsoft APIs, it was somewhat promising. Uh, with the Google APIs, there were some challenges. We could not achieve a good accuracy, and there was a high error word rate. So like there were different challenges involved. Uh, the APIs which we are using, they are in different language, and your team members, they don't have expertise in that language. So how do they interface? How do they come at common ground? Uh, so some a different person was exploring this Google API with his own application he developed. So you cannot uh, reduce like what were the exact problems, but these were the numbers we came up with. Accuracy was pretty less. System was continuously listening, and it did not analyze a break in between sentences. So that was kind of garbling or ingestion to the system for transcription. So we were not getting expected output, and we needed to have a better polling mechanism. Like when you are speaking and that signal goes to the system, so it should know when to stop. So we did not implement that. Uh, Audio length parameter, like how long it's going to listen to that. So that's how Google API accuracy was pretty less. A few words about the Splice API. Splice is a structured programming for linguistic queue extraction. So when we do linguistic analysis and we come at different parameters, like I was saying, there were 60 plus different parameters which Splice gave out for one single sentence. So as far as this deception was concerned, so we picked 4 of those, like immediacy. We checked for the number of pronouns, or we checked for difference. So I'll explain like in very brief. So immediacy is when you ask someone a question and then he responds immediately, or that happens only when he has a pre-mediated response in his mind what he wants to answer. So that's a cue for deception. Pronouns, if someone is making a lot of use of pronouns, that's accepted as a deceiving technique. And if you're talking to someone and he defers it, like you ask, what did you eat? And then he is thinking and then maybe saying something. So he's deferring the output and not coming up with an exact answer. So that's deference. And the complexity with which one replies, that's also a deceptive measure, which a lot of smart people, they employ. So these were the different cues which we were trying to extract, and we did not exactly go into different algorithms because this API was already published, and we imported their methods. And people were not versed in um, one common language. Someone was well versed in Python, someone else was working in uh, Java based technologies, and to come together and build a platform with such constraints, it's not an easy task. So but still we prepared a kind of dashboard. So as and when it was listening to a sentence which someone spoke, like in current example, if the speech was just a very small sentence, I think I need to say something else. If someone is saying like this, so our system actually picked, and then it ran through that transcription through Google APIs, and then it went through the Splice, and then we got different outputs for immediacy, for difference pronounce levels, and all those things, and then we were able to project them onto a dashboard, which could make sense to a lot of people in that domain. So that was how this project was completed, and it's an example of how uh, data analysis is done, and like you see the entire journey. Like we are capturing audio signal, we are making transcriptions, and then uh, 1 second, there are a few people waiting to get admitted. Okay. So yeah, so you see entire journey, like those audio signal transcription and then running through Splice APIs and then coming up with these numbers. And how all of this started was uh, there was an intention to mix uh, business, sorry, not behavioral science with technology, and come up with a solution that could catch deception. Like there are a lot of people who employ these techniques. Uh, uh, the kind of examples which I gave at whenever you are going to a different country, you are at immigration check post. The person there, he asks you several questions. So it's not that he's interested only in the answers which you are giving. If you show some suspecting behavior, you are sidelined, and then further questions are asked. So there's a definite science behind all of this and how people interpret these things. So we tried to come up with a solution on based on that science, and it was a fulfillment to one of the project reports which I did last year. Uh, so going forward, like this solution was far from perfect, as you might have made very good guesses. It did not give a continuous and acceptable output. There were development challenges. There were time constraints. Uh, the graph which I just showed, these values are pretty instantaneous. Instead, if you're able to get moving averages, they show a better, uh, uh, like they are the better characteristics rather than instantaneous values. So, and we were trying to make stream processing functional, but was stream processing actually required? Like, as and when someone is speaking, can you actually theoretically or technically at that point of time itself uh, process it, analyze it, and then produce graphs? So that was probably a mistake on our end. Instead, we could have just taken some micro batches, like when someone is saying, hear it for 30 seconds, process it, and then display those charts. So that could have been done. And obviously, when we are interacting with web APIs, there was a latency involved in getting uh, different outputs from those Microsoft Cognitive APIs and Google speech to text APIs. So going forward, like we are approaching our conclusion. Just keep in mind that learning is lifelong. I worked for several years back in India. Before that, I did BTech in electronics and instrumentation. I was very new to software when I joined L&T Infotech. For initial, like a couple of years, things did not make a lot of sense to me, and there was a lot of frustration. So you have to find your way through it. You should not have a like complacent attitude. Uh, everything which comes across has as a message for you. Everything has a learning for you, and it goes on. So I switched companies when I saw that I was approaching a plateau. I could not like rather than switching companies, I could not do much. So that's how I thought of coming to the US and then enrolling in this master's program. Uh, and that's my message. Like learning is lifelong, and this is like this philosophy of learning. So I know this is all non-technical stuff, but I want every one of you to take some message from this presentation. Like, and it's not my personal knowledge. I heard it over a podcast. There was a very famous cancer specialist in California. He was speaking something about how he saw learning and how he used to philosophize about it. So he said that when we start into a field, so like we are student or we just join a company, we don't know how to react to all the stimulus which we are getting. So it's called as unconscious incompetence. You don't know how you have to respond or how you have to do things. And once you pass that phase, you start enjoying your journey. You develop some interest. You get some motivation, either someone appraises you or you get an appraisal in monetary form. So that pushes you towards taking up learning on a higher level. So and then you kind of realize that, oh, I was incompetent, and that realization point begins your conscious incompetence, that you understand that yes, you are incompetent and you have to work hard. So you spend some years into that phase, and once you're done with that, uh, you reach conscious competence. You know how competent you are. You know your market value. You know if you are going to switch companies, how much other companies going to pay you. Or it's not only about monetary thing. You become competent essentially, and in long run, we all aim for last stage of this learning, which is called unconscious competence. So like, even if I am sleeping or I'm dreaming, like if some thought comes to my mind or someone asks me a question, I should be in a position to answer that. So that's kind of unconscious competence, which probably we all can aim for. So that's all from my part. Over to you, Tanu, and probably we can take up some questions if anyone has.
Thank you, sir, for giving your valuable insight. And now it's time for question and answers. So those who are interested can either raise your hands or write the question in the chat box. So first question was by Krishna Prasad. Lalit
Oh,
sir,
now
the question is,
I
how
yeah,
AI
please go
helps
ahead.
in data science, load balancing in cloud environments.
How AI helps in data science and load balancing. That's kind of mixing a lot of things, a lot of buzzwords. So so you have to understand it from a discipline point of view that you cannot segregate AI from data science. So artificial intelligence, it's dependent on different things, like how technically advanced your instrumentation is, your mechanics are, and what kind of responses you are getting and what data you are getting, and and if you have some knowledge about control system, you have a recursive feedback loop which goes into this artificially intelligent systems. So they learn by experience. So so you cannot segregate these things. So AI and data science, like I don't see a lot of difference. Like one is subset of other, and in some ways the other one is subset of the former one. And as far as load balancing and AI are concerned, like uh, on a higher level, uh, like we generally leave it to the system as far as cloud is concerned about managing load balancing. We define some definite values, like if the load is approaching that point, so we relegate some of the load to another system. So ai AI applications in load balancers, like I don't have a clear answer to that. Maybe I'll research and get back at some other point of time.
Okay, thank you, sir. So, sir, next question is, did data segmentation plays any role in deep learning? This question is asked by Bhavesh.
So Bhavesh, like I'm kind of surprised. Like I did not touch these words in my entire presentation, like data segmentation and deep learning. So I don't know from where you get an idea of putting this question forward. Like if you would stick to the things which I explained, if you have questions about that part, I'll be more than happy to answer them. Uh, but this part I leave to yourself. Like probably you should learn more.
So, next question is, how about syntactic and semantic analysis? This question is asked by Krishna Bhati.
Semantic syntactic analysis, I mean, on a higher level, these relate to text analytics and the operations you perform to get those analysis, the mining in those text inputs. So yeah, on a higher level, these are all like the sub levels of text analysis, text analytics, and text mining. So in order to get there, like dictionary definition, I would again suggest you to go to Google and then see how it relates to them.
Okay, thank you, sir. This completes the question and answer round. Now over to Tanu ma'am for.
It was an enlightening and session which was brighten our knowledge in cloud and data analysis. Despite of the time difference in between the countries, you tried to available yourself at this odd hour. Thank you so much, sir. Now, may I request our head of department, Mr. Kaushal Shakya, for the vote of thanks to our speaker and participant. Over to you, sir.
Yeah, okay. Thank you, Tanu, madam. Honorable Speaker Sir, Mr. Lalit Saraswati, organizing team and all the participants. It's my privilege to have been asked to propose a vote of thanks on this evening. I, on behalf of Department of Computer Science, Satyug Darshan Institute of Engineering and Technology, extend a very hearty vote of thanks to Honorable Speaker Mr. Lalit Saraswat, who honored us with their presence and took out valuable time of his busy schedule. I must mention our deep sense of appreciation for him as he nicely described the paradigm shift of software development, Azure, and many other topics of the interest of computer science that can be useful to faculties or students. And the way he explained these topics is really exemplary. I heartily congratulate and thank to all the participants for their active participation. And at last, but I extend my deep thanks to our Department of Computer Science for successfully organizing this event. Thank you all for your contribution. Thanks to all the participants also.
Thank you, sir. It was a pleasure being here. I really enjoyed doing this thing. Uh, it was the first time for me to address so many people uh, and share my learnings. And I tried to touch different parts, technical, philosophical, and the case studies which I had worked on. So I hope everyone benefited some from it. So thank you so much for your time. It was a pleasure being here.
Okay, thank you, sir. Thank you, Lalitji. Thank you very much.